This section's all about hyperbolas, and what hyperbolas look like are these two lines that open to the left and right, as you see here, or they open up or down, as you see over here. So really what a hyperbola is like two parabolas from one single equation. So the equation for the one that opens left and right is down here, x squared over a squared minus y squared over b squared equals 1. And the equation for the vertical one is over here, y squared over a squared minus x squared over b squared equals 1. Now the main difference here that you'll notice is that on the left one, it's the x squared term that's positive, and it's subtracting the y squared term. On the right one, it's the y squared term that's positive, and it's subtracting the x squared term. So the a and b stay in the same locations. For ellipses, they switched around, but for hyperbolas, a and b stay in the same locations, and we just switch the x and y. So how are you going to remember which one is which? Well, when the x squared term is positive, this transverse axis connecting the two parts is on the x-axis. So this transverse axis is on the x-axis. So when x squared is positive, that line connecting the two is on the x-axis. When y squared is positive, when this term is positive, it's on the y-axis. So basically, if x squared's in front, it's a left and right one. If y squared's in front, it's an up or down one. The other features of these hyperbolas are the foci. There are two of them that are where you'd expect them to be, right in front of the parabola that's opening. There's the vertices, the vertices, I'm sorry, that are where you would expect them to be as well, and the minimum of the hyperbolas. And there are these other 2 points. These aren't called covertices anymore, but it's just a way for us to establish these asymptotes that run along these axes. Those B points help us determine what those asymptotes are, because this hyperbola will never cross these asymptotes. It'll always stay on the other side of them. This is a quick chart to help you a ton in this section. I would just pause the video right here and write everything down. I'm going to keep on explaining it though. Remember that if the x squared term's in front, it's a horizontal one. That's left or right. To find the two asymptotes, it's the two lines that you will find are y equals plus b over ax and y equals minus b over ax. If you want to graph those are what they would be. And the vertices are plus and minus a, comma 0, because they're on the x-axis. For a vertical one, it's just opposite. The y squared term's in front, it's vertical, it opens up and down. The asymptotes are plus a over b and minus a over b, and the vertices are 0a and 0 negative a. However, the big difference here is this equation for the foci. So for an ellipse, the equation was c squared equals a squared minus b squared. But the foci for a hyperbola is c squared equals a squared plus b squared. It's a very big difference between hyperbola and ellipse, which is something you need to mark. On to the first example. 25y squared minus 4x squared equals 100. And it says identify the vertices, foci, asymptotes of the hyperbola, as well as graph it. First we got to set it equal to 0. Divide everything by 100. That's y squared over 4 minus x squared over 25 equals 1. Now we can determine what a, b, and c are, as well as know which way this opens. I see the y squared is in front, so I know this is going to be one that opens up or down. However, I don't know where yet. So if I know that this is a squared, this is b squared, because for a hyperbola, a squared is always in front and b squared is always second. So a squared equals 4, a equals 2, b equals 5, and to find c squared, it's just c squared equals a squared plus b squared. That means c squared equals 4 plus 25, 29. C equals the square root of 29. Now, because I know this is a vertical one, I know that the foci are going to be at 0, 2, and 0, negative 2. I know that the b is going to be here at 5 and negative 5. Or I'm sorry, I put the vertex at 0, 2 and 0, negative 2. The foci are at square root of 29. I'm going to go ahead and estimate what that is. It's about 5.4 when you plug it into your calculator. So the foci are somewhere here and here. And this graph's going to look something like this. To complete it, though, you need to show that there's a box running through the vertices over through B and back down. And there's these asymptotes running through the center. Just so we know that it can't cross over. So this graph is going to look something like this. And I'm going to label a couple points just so people know what I'm talking about. So this is 0, square root 29. I'll label one of the vertices. This is 0, 2. And I'll label one of these two. That's 5, 0. And we know that the other points are just the negative variation. Alright, this is the second example. It's just going backwards. So write the equation with foci at negative 4, 0, 4, 0, and vertices at negative 3, 0, 3, 0. So I have to draw myself a little graph just so I know, like, generally what type this is. So the vertices are at negative 3, 0, and 3, 0. Foci negative 4, 0, and 4, 0. So it's going to look something like this. Okay, this is a left and right one. That means that the x squared term is going to be in front, and it's going to subtract the y squared term. So the equation is x squared over a squared minus y squared over b squared equals 1. Now we just need to plug in the information. We know what a squared will be. It'll be 9 because the vertices are 3, so 3 squared is 9. We don't know anything about b squared though, so we have to solve for it with the equation c squared equals a squared plus b squared, like we've been over. C squared, okay, c is 4, so c squared is 16. 16 equals 9 plus b squared. 7 equals b squared, so b equals the square root of 7. So we can go ahead and plug that in. We have x squared over a squared, which we said was 9, minus y squared over b squared, which is 7, equals 1.